Hi, I'm Jordan Collard, and this is my recorded video for SIT232 Past Task 1.1p, Selection and Casting. The first task here saw us using nested if-else statements to get the word equivalent of a single-digit integer that's entered by the user. In the event that the user enters a non-integer value, I've used exception handling to throw a format exception. And this is catched by enclosing a call to the string conversion in a try-catch block, just listed up the top here. For code readability reasons, I've opted not to have the nested if-else statements in the try section of the try-catch block, just to keep it small and so we can see the format exception just straight off the bat. By the time the program was to even get to the if-else nested statements, it's already ensured that a real integer was actually entered. And it just looked a bit neater this way. And if we give that a quick run, give an example of that. Enter a number, let's go with a real one, 5, and it spits out the word equivalent. And let's see that format exception. I'll enter A, and there we have our format message thrown, as well as a more specific thing. With our second task, it is basically just adapting that first task into switch case statements, replacing the nested if-else statements. So there's a number of advantages to this method. It has speed advantages. If it has more than 5 items, it's implemented using a lookup table or hash list. So all items get the same access time compared to a bunch of if-else statements. It's also, a bit more compact, clear, easy to read. And again, we've, used that try-catch statement to throw a format exception. When executed, it runs exactly the same way, more or less. The third task, it involved manually evaluating potential errors and formatting issues in some code snippets. So I've jotted down some of the issues before fixing the code and running it with the output displayed in Visual Studio. And just to quickly go through a couple of them, we have snippet 3, and these are some of the issues that I noted just from looking at the snippet. So we've got formatting issues. A bracket should be placed on the following line. Line 2 of the snippet, main is a lowercase m. That's probably going to cause an issue, so we'll make that a capital M as well as that bracket. And the score variable could be an integer in this snippet scenario, just to save space. A double is 8 bytes and an integer is 4 bytes. So that's something to consider. And when we fix the code, you can see how it looks just a bit neater. It looks like it's going to run with no issues. And output is also included in this. And I've done that for both task 3 and task 4. Task 4 was more or less the same as task 3, except making more predictions on what the output was going to be of the codes before we went into fixing them. With task 5, that was the microwave task. And the microwave cooking task, which, in this task I implemented 3 switch case statements, as the microwave manufacturer doesn't recommend heating more than 3 items at once. So it seeks a number of items and a single heating time from the user and performs the appropriate calculation to return the recommended heating time for those scenarios. And, for example, if there were 2 items that were going to be cooked, so just key in 2, and the heating time was 30 seconds, it would add 50% to that cooking time, so 45 seconds should be what's returned as the recommended heating time. And in that case, it's correct. Just the pretty simple calculations for those events. If there was a if the user wanted to heat 5 items at once, and it would come up with that manufacturer does not recommend cooking that. The maximum should be 3. And with the final task, the sixth task, it was about casting the result of an operation on two integers to a double. So I've used implicit and explicit casting with a recommendation to have one of the variables initially declared as a double. It might just be a bit better this way. And so maybe this is a good one to run the debugger on to get some information here. I'll just run with the start debugging. Maybe I'll just jump into some of these, and we'll get to see these local variables get their values assigned, and we'll see the type as well as we go through this. So the sum is an integer, declared as an integer and given the value of 17, with the count also an integer given the value of 5. And when we perform that calculation of dividing the two, it as it lists in the comments of the code, because the variables are integers, it's not going to return the precise average, with a decimal 3.4, which would be the accurate division or the accurate average. So we'll, continue stepping into this in debugger mode, and so this is where we can use some explicit casting with our double average variable. And explicit casting, just in the parentheses, we include double before sum, which will temporarily change that value, the sum, to a double, and step into it, and it gives us that 3.4 when it does that. So that's great. Although, here I've said it is better to make one of the variables a double, so that way when we do the division, instantly the average is accurate. The only other casting method that we've used so far that I know to exist is, using the convert class with the toDouble method as well. So I've just included that as well. Thanks very much.